Have you ever wondered how can this water strider walk on water? Or how can this paperclip float even though they're far denser? Why some liquids flow slower than others? Or why different liquids have different boiling points? So, how do these phenomena occur? Well, these phenomena can be explained by a concept of intermolecular force, first proposed by the Dutch physicist Johannes Diederik van der Waals. It is simply the attraction between molecules. Let's take water as example. Intermolecular force happens between the water molecules, meaning between the H2Os, and this affects the properties of water. Now, let us see this intermolecular force in action. Isn't it almost magical how it can literally walk on water? Well, it's not magic. It is simply because of intermolecular force happening on the molecules of water. Because of strong intermolecular force, the water molecules are highly attracted to each other, creating a film-like surface that can hold weight that would normally sink. This further explains why water flows together when spilled and not break apart. Well, speaking of flowing, did you know that intermolecular force is also the one responsible why different liquids flow in different ways? Let's take water and oil, for example. Now, both the water and the oil have intermolecular force present within their molecules. So, why do they flow differently? The determining factor to its viscosity is the strength of the intermolecular force. The stronger the intermolecular force, the more viscous a liquid is, which means the stronger the intermolecular force acting between a liquid's molecules, the slower it flows. In the case of water versus oil, since oil flows definitely slower, we can say that the intermolecular force acting in the oil is much stronger. One of the last things in mind when we talk about intermolecular force is boiling point. But we need to realize that intermolecular force is primarily responsible to why different liquids boil at different temperatures. Generally, the stronger the intermolecular forces are, the higher its boiling point. This is because there is more energy needed in order for the molecules to break free from liquid into gas. Hence, in oil versus water, we can say that oil has greater boiling point than water, which is true since water boils at 100 degrees Celsius and oil boils at 300 degrees Celsius. Now you know why this, and this all happens. They can all be explained by the intermolecular force that acts between their molecules. Remember folks, before you think something is magic, always look at its molecular level.